Hi friends, a very good evening and thank you for joining in. Could you please confirm if I'm visible and audible in the chat window so that I know that things are working as expected and there are no glitches whatsoever. We'll get started in a few minutes. We'll start mostly at 7:02 or so. Also, our team has put up the link to the live sessions, the schedule of live sessions that we have. Cool. Okay, everything seems to be looking good as the confirmation comes in from the chat window. Okay, let me also start sharing the screen here quickly. Okay, the screen share is also working as expected. Okay, all good. Good. We'll get started in just a few minutes. Since we have a few minutes, I'm happy to answer a few questions. So that's where it would be. So Roy says, is the difficulty of the scholarship test equal to the practice test? Not exactly, but to get a real sense of the problem types that you will encounter, just check out the scholarship test that we had last year. That's why we put up the last year's scholarship test with the same syllabus, everything same, so that you get a realistic idea on what the test would look like, right? So I believe that might be the better one. So Akash says, in the last live session, Q2 explanation was not clear. Akash, why don't you just go to that live session video, which is publicly available on YouTube, and leave a comment, and we can clarify whatever your concern is, right? Just rewatch the explanation, and if there is a follow-up question, feel free to put it in the comment section. We'll try to answer as quickly and as many as possible. Ayush says there will be more number of participants in the scholarship test. We also hope so, because we want to have a good participation, and also we want to have this open to as many students as possible. So that's the whole reason why we delayed it slightly, and we hope this is a good time, because this is also summer vacation for most students. All the people who come through the scholarship test can also use the course for the next few months during the summer vacation to make the most out of it. Cool. Is the GST included in 100% scholarship? If you're getting 100% scholarship, you don't have to pay anything, including the GST, because GST is like a goods and services tax. If you pay something, you pay a percentage on top of it, right? For a regular course, just like any other organization in India, we have like 18% GST. If you're paying 0 rupees, 18% of 0 rupees is 0 rupees. So you don't have to pay any GST. Cool. So somebody is asking about data structures and algorithms course. So in the data structures and algorithms course, what we do is we try to teach the concepts using pseudocode. And that's extremely important, because students can pick any language of their choice. Right? So what we do, again, this is a very standard strategy that is followed at most top universities of the world, and our whole data structures and algorithms content itself is designed based on Corman Leeserson's book called Introduction to Algorithm, often called as CLRS textbook. It is a standard textbook at all the IITs, at IISc, at Stanford, at MIT, you name all the top universities of the world, it's a standard textbook. So we follow that notation to explain everything using a pseudocode, and we provide code snippets in various languages. We provide code snippets in C, we provide code snippets in Python. I believe for some of the problems, we also provide it in Java, if I'm not wrong. So we want to give students that flexibility to pick whatever language they want, whatever is their favorite language, to implement the data structures and algorithms. And also all the problems that we solve as part of the placement prep course, they're solved more from a pseudocode perspective, because we understand, and we provide source code in various languages. But once you get the pseudocode, translating it is simple programming oftentimes. Cool. Somebody says, should I spend 1 or 2 lakhs on a laptop to learn ML and AI? Please don't do that. It's not worth the money. Most machine learning, you can learn it using an entry-level laptop, entry-level student laptop. Just use online services like Google Colab to run most of your code. I use Google Colab extensively myself. Even though I have a decent laptop, I'm just used to it because it's easier for me to share my notes, share my code snippets with my teammates. So that's what I also follow extensively. Of course, if you're building a large software, that's a different beast altogether. But for learning purposes, I think there is no point spending lakhs of rupees on a high-end desktop or laptop. Cool. Again, we'll keep the discussion mostly to Gate, and let's avoid other topics here. Is computer organization skippable in Gate? Chetan says this. I would say don't skip it, Chetan. It's actually a fun subject. I mean, you can check out some of our free videos that are publicly available, because I really enjoyed creating the content for computer organization with the help of all of my mentors and team. It's a beautiful course. I mean, don't give up on it so quickly, because while you may not be able to score all the marks in COA, because there will be a few tricky questions, you can easily solve 50 to 60% questions there. Why lose out those questions? I think COA has about 7-8 marks. You can easily score 4 to 5 marks there. Why leave those 4 to 5 marks? That could be a determinant factor in the final rank. So don't leave a whole subject. Maybe you want to leave the harder topics here and there, or focus less on them. But don't leave a whole subject itself, because there will be easy questions from every subject. Do you think the competition in Gate will be more this year? We don't think so. The same question was asked of us last year also, but I don't think there will be significant change in competition per se, because at the end of the day, people who are clearing it in their third year will not be able to join till the time they finish their fourth year, right? So the equation doesn't change, and the competition, even last year, we haven't seen it significantly increase as compared to previous years. It's more or less the same. Will there be a syllabus change in 2022 Gate? We don't know that. We are not part of the organizing committee. It is only the organizing committee at IIT Kharagpur who will be able to say that. There is a very low probability of that happening, because Gate doesn't change syllabus every year. They change it once every few years. That too minor changes. Last year we had some change. Minor, not too big, but there was a change. So there might be minuscule change this year. The probability of a significant change is very, very low this year. Again, Akash is asking about the difficulty level in scholarship test. That's why we gave you the sample scholarship test, right? Please, this is the scholarship test that we used last year. So that will tell you, it'll be of the same difficulty, same hardness, because the objective here is not to make it too hard. There's no point in it. And anyway, it's a rank ordering, right? It's not absolute marks, it's rank ordering. So no problem there. We strongly recommend you check out the scholarship test that we had last year, so that you get accustomed to the user interface, number one. The whole UI part, you're comfortable with it, and you also get a sense of types of questions and hardness of questions that you'll encounter. There will be a mix of easy, medium, hard. The number of hard questions will be very small. Can a non-student clear Gate? Okay, I think Mukesh is, can a non-CS student crack Gate by taking your course? I think yes. So even if you look at some of our interviews of top 100 rankers last year, we have had a good bunch of folks, even in the top 100 ranks, who come from non-CS backgrounds. That's possible. You just have to put in slightly more effort, because you may not know a lot of core computer science subjects. You will have advantages yourself. For example, non-CS folks tend to be good in engineering math, which is also very scoring in Gate. Okay, it's 7:05, so let's get started. We'll continue this Q&A a little later. For now, let's just continue our discussion and go to the C programming, right? So we'll start, we have 6 questions if I'm not wrong today. So we'll go through the 6 questions, and we will spend some time in the Q&A at the end. Cool, so fairly simple, straightforward. This is a C programming live session 3. We have one more live session for C programming. After that, we'll start data structures algorithms. All live sessions for C programming, data structures algorithms will be publicly available for the benefit of everyone, especially those who are preparing for placements. Cool. The topics here are strings, pointers, and some basics of functions. Cool. So here is the first question. Again, let's focus on solving the questions now. We will discuss general questions at the end of this 6 questions. So let's focus on solving these questions. Okay, let's solve these questions now. I will answer the general questions at the end, as I just mentioned. I see some variability in answers. This is a simple question. You might expect similar questions for about 1 mark in GATE. Again, I see some variability in answers. People are choosing B or C or D. Please revisit your answer once while we wait for others to put in their answers. Again, always draw diagrams. Please draw diagrams of where something is in memory so that it's easier for you. You will avoid silly mistakes. Okay, so let's tackle this question. So what we have here, like if you see this, right? So what you have here is basically a array of pointers, right? It's an array of character pointers. That's what you have. And each of these character pointers will point to each of these strings, right? So literally what you have here is, okay, let me just draw this so that it's easier for you. So you have something like names here, and names is a pointer. It's an array of pointers, right? So names is an array of pointers. So this first location, let's say 0, 1, 2, 3, 0, 1, 2, 3, 4, right? So the 0th location is pointing to Suresh, right? The first location is pointing to Shiva, the third location to Sona, the fourth one to Biju, the fifth one, or the fifth location to Ritu, right? So this is how things are looking internally. Now you have int I equals to 0, you have a character pointer. Now t equals to names 3. This is simple, right? So look at this. T is now pointing to names 3. Names 3 is this. So t equals to names 3, right? So t will also point to. So what does it mean? Remember, t is a character pointer. So if t has this value which is there, if t has this value, what does it mean? It means t is also going to point to Biju, because it's a character pointer, right? It can point to a string. Now you're saying names 3 equals to names 4. So what are you doing here? Whatever is the pointer value here, you're copying it into 3. Again, doing this carefully is important. While it's a simple problem, if you can solve these problems carefully, it'll improve your thought process significantly. So whatever is the value here, we're going to copy it now. So what does that mean? That means this will no more point to Biju. This will now point to Ritu. That's what is happening at the end of this line. Now we are saying names t equals to 4. Names 4 equals to t. Now what does names 4 equals to t mean? Names 4 means this pointer. This pointer we are saying pointed to make this value equal to t, which means now this will no more now. Okay, let me just erase the, okay, got it. So this will no more point to Ritu. This will now point to Biju. That's what is literally happening here, right? So this line is also executed. Now we are saying printf names I plus 0. What is I here? I is 0. So we are saying names 4 is what we want to print. Now literally what happened here, look at this. So the third pointer is pointing to Ritu. The fourth pointer is pointing to Biju. Now we are saying names 4. Names 4 basically means it will be this. What is it pointing to? It is pointing to Biju, right? So what exactly happened here, if you think about it? We just used a temporary character pointer to swap the values in these two pointers, right? So what we have here is an array of character pointers. We swapped the pointer value here and here using the temporary character pointer. That's what we did. So the answer will be Biju. Simple, right? It's a simple swap. So this is like a swap functionality using a temporary variable, but we are swapping two elements in a array of pointers. That's the only small trickiness. That's it. Fairly simple, straightforward problem. This is a typical 1 mark problem by gate standards, right? Again, I've seen some of you say D. Again, somebody is saying, why can't we use some other technique? The question is not about using some other technique. The question is, what is the output of this C code? That's the question at hand, right? There are many, many ways through which you can swap. We are not saying there is only one way to swap. It's a simple question. It is somewhere between easy and medium by gate standards, but a simple 1 mark question, typically. Cool. So let's go to the second question now. Okay. So what is the output of the following C code? So first you have this snippet of code followed by this snippet of code. So there are two values that it will print with a space between. It will print two values with a space between them. You have to fill this value and this value. It's a NAT. Again, please be careful here. Again, please be careful with this question. Somebody says, I can't read C, only Java. Then I think you lose all the marks in C programming in Gate. Gate doesn't have Java in the syllabus. It only has C programming. Please take your time. It's okay. Just be careful with this. Again, always draw. Look at what is pointing to what is the data type of what. Keep that in mind. Draw these stuff just like the way I've shown. Drawing the whole pointers where things are pointing to is extremely helpful to solve problems like this. So the technique that I want to get your attention to is keep drawing how the memory looks. Take your time. Take your time. This is also very similar to what you can expect in gate questions, maybe for 2 marks. There are some of you who have made some mistakes, so please revisit your answer. Some of you who have made silly mistakes also. If you know how pointer to an array works, this is a straightforward question, very similar to gate level. I'm very happy to see most of you got it right. Actually, very happy to see that. This is a slightly tricky question, slightly tricky. I'll wait for a few more seconds for those who are tackling this question now to finish, as well as people to correct it. Yes, by gate standards, this question will be considered as a tricky question. Yes, that's true. So somebody says, how much time does it take to learn C at gate level? If you've already studied C once, you can finish whole of C programming in 1 to 1.5 weeks, max 2 weeks. Okay, so let's tackle this question. So just curious, okay. So is the red font size or the font width better, or is the blue font width better? Just curious. Anyway, I'll use the thicker one right now. Okay, let's solve it. Okay, cool. So very simple. You have two functions here whose function declaration is made. You have the two functions fun1, fun2. One thing that you have to observe carefully here is, if you look at this data type here, if you look at this, what does this mean? Again, that's very important to understand. This says that it is a pointer, it's an integer pointer, let me put it carefully. It's a pointer to an integer array of size 3, to an int array of size 3. So it's very important to read this carefully. Okay, so it is a pointer to an integer array of size 3. That's what it means. Okay, that's very important to first get it clearly. Now, okay, so what do we have? We have an array like this. So this array, okay, so the 3 elements. So what will you have here? You have array 0, which will point to these 3 elements, which is 10, 20 and 30. You have array 1. It's a 2D array, right? This is a 2-dimensional array, right? So you'll have a pointer which will point to 40, 50, 60. So this is 40, this is 50 and this is 60. Simple. Now we are saying fun ARR, right? So you're calling this function. So what is the input to this? The input that you're passing here is the whole ARR here, right? Simple. So that part is cool. Now we are saying, so what will P point to now? That is important, right? So P will initially point to, so let me change the color here. So P will initially point to this. Okay, to this, again, what is the type of P? P is a pointer to an integer array of size 3. So P is a pointer to this whole array, not to the single element. That's important for you to recognize. Okay, so that data type is important, because when you do arithmetic, that becomes extremely important. Okay, so P is pointing to this because you passed ARR, which means ARR 0. Now we are saying plus P. So what happens here? Remember, P is a pointer to an array of 3 integers. So when you increment P, where will it point to? It will now point to this. It will no more point to this, right? See, you're incrementing by 1, but the size of this whole thing, P is a pointer to an array of 3 integers. So when you do plus P, it will actually point to this first. Now you're trying to print something. What are you trying to print here? Star P plus 1. So when you say star P, what is a value stored at P? P is a pointer to this whole thing. Look at this. P is a pointer to this whole array. When you say value stored at P, you will again you can do this conversion from pointers to arrays. That's another way of thinking about it, right? So this whole thing basically means in the array that P is pointing to, what is the first element? Simple logic, right? So star P plus 1, again, there is a star here, there is a star here. So this basically means star P basically will basically get us here. Plus 1 will get us here. These are pointers, and value stored at this location is 50. So we will print 50 first. Simple. So the first value will be 50. That part is clear. Okay. Next, okay, after this we are calling again this function, and what are we passing? We are again passing P. So P is still pointing here. We have not changed P. P is still pointing to this whole array of 3 elements. Okay. So now what are we doing? We are doing, again, this P is now called as A, right? Because you're passing this P here, and internally within this function it's called A. So now A, which is the local variable here, is pointing. Again, A is also a pointer to an array of size 3, right? So that's why I'm just using this here. Okay, so you're saying minus A. So when you decrement A, what happens? Remember, A is a pointer to an array of size 3. When you decrement it, A will now point to this array, right? So A will no more point to this, A will point to this. Now look at this print statement. This is where things are slightly tricky. Remember that this is here, this is here. Look at the parenthesization. That's where some of you have done a mistake. Okay, first what are we doing? We are saying A plus 1. What is A? A is a pointer to this array of 3 elements. So when you do A plus 1, what happens? A plus 1 will point to this array. So A plus 1 will point to this, A plus 1 is a pointer to this array of 3 elements. That's first. So A plus 1 is simple, it's resolved now. Then you're saying star. So when you say star, what do you get? You get a pointer to this, right? Then you're saying plus 1, right? So look at this. So star is also resolved. Then you're saying plus 1. Plus 1 means it will point to 50 now. Now you're taking star. Star basically means value stored at this pointer, which is 50 again. So it will again print 50. Okay, those of you who said that the answer also contains 51 probably messed up this plus 1 and parenthesis. That's it. The answer is actually 50 and 50. That's it. Again, it's very simple to understand if you draw these diagrams and if you keep changing the pointers while keeping track of the data type. So the two tricks that I would recommend here is please draw, because it will help you. Number 2 is keep track of the data type. Keep track of the data type of each variable or expression that you're working with. Okay, that's very important, because if you don't know that, all the arithmetic will be messed up. Once you know this, everything falls in place. So this is typically by gate standard considered a tricky question, typically a 2-mark question by gate standards. Cool. Okay, somebody is asking this question. So I think I just mentioned this, right? So if you have this notation, this is basically a pointer to an array of 3 integers. That's what this means. There was the previous question, right, where I told you what it means. So if you have this sort of notation is different. This is an array of pointers. This is an array of character pointers. Okay, again, this is something that we explain in lots of careful detail in the course videos. This is an array of character pointers, right? So again, look at this. There is no parenthesis here. This is an array of character pointers. That's why we try to cover both of them in these examples. This is basically a pointer. So this top of notation is basically a pointer to an array of 3 integers. Okay, it's pointer to an array and array of pointers. This is where most people get confused. That's why these types of questions are very, very common in GATE, especially with respect to pointers. Cool. So let's go to the next question. Again, we have some of the free videos for C programming also that you can check out on our website. For almost every course in GATE, we have a few videos, typically the first chapter, freely available for everyone to go through. This is a simple question about strings. Again, I see broadly 2 answers. I see some mistakes in this also. So please revisit your answer once. Please go back and check it carefully. This is standard string copy and string concatenation and string comparison functions. I see a lot of you who I think have made a silly mistake here. This question is typically by GATE standards considered an easy question, easy to score, typically like a 1-mark question. Please don't mess up and lose these marks. Please revisit your answer, folks, quickly. In the meantime, I'll also copy this just to make sure, because I did not run this code. Just give me a second. I think my answer is correct, but I just wanted to be sure. Yeah. So the answer should be 0. I don't know why some of you are saying 1. Anyway, let's dissect it, right? So you have this, again, we are in the same function main. So we have a string called dills and another string called dafo. We have a third string that is just initialized, no value, that is just created, no value placed here. Then we are saying int I equals to, let's evaluate this now. So first, what are we doing? We are doing a string copy. So what does a string copy do? Whatever is here, it will get copied to string 2. So now what is your string 2? While string 2 has capacity up to 20 characters, string 2 will now contain dills, right? So string 2 will contain dills \0. Right? That's what the resultant of this is. Okay, let me write it here just to be sure, just so that we are all on the same page. So this will be dills \0. Then we are saying string concatenation. This is standard string concatenation. String 3 followed by whatever this resultant is. String 3 is dafo. So once we do a string concatenation of this whole thing will give us dafo, because it's string concatenation, right? Dafo dills \0, obviously. Now we are doing a string comparison. How does string comparison work? String comparison looks at each of these strings. It compares D with D, right? So D and D are the same, so they are the same value. This and this are the same value, so on and so forth. It will check everything. Since both the strings are the same, it will result a value of 0. I think that's where some of you got confused, right? So just look at the string CMP documentation in C. Just give me a second. strcmp C function reference. I think that's where some of you got confused. Okay, so let's look at the reference itself. Okay, look at what it says. Okay, so string 1 and string 2, it will give you 2 strings that you can compare. It returns a value of 0 if the contents of both strings are equal. Less than 0 if the first string does not contain a match and has a lower value, right? So it's basically doing like a difference between the characters. So it's literally doing string, whatever is there in string 1 minus string 2, right? From an alphabetic order perspective. So if string 1 was less, it will return a value less than 0. If it's other way, it will return a value greater than 0. Otherwise, it will return 0. I think that's where some of you got confused, and hence the result of this will be 0, not 1. Okay. So I believe one of the causes of error here is some of the students not understanding how the string compare function itself works. But otherwise, it's a straightforward question, right? Simple, straightforward question. Again, some of you may have committed silly mistakes also. This question is actually fairly easy. I thought everybody would get an answer. I was surprised when some of you said 1 is the answer. I was actually thoroughly surprised because again, the simple way to think of string comparison function in C is, if you have 2 strings, let's assume I have some A, B, C, D as my string 1, and let's assume I have C, D, E, F. What it's trying to do is it's trying to do a subtraction operation. It will take the integer value corresponding to A, the ASCII value, minus C. Right? So since C is larger in terms of ASCII value, this will result in a negative value. So the way string compare works internally is through an integer subtraction, character by character. That's how it works internally. Okay, that's how alphabetic ordering is done by string compare. Okay, if you understand how string compare works internally, this is straightforward. Okay, again, some of you may have gotten confused that string compare returns 1, so just be careful with that. Cool. I'm happy that for many of you, this was a good clarification and correction of your concept. Okay, so let's go to the next question here. It's okay to make silly mistakes. It's okay. That's perfectly okay. We all make those. It's through these. It's better to make a silly mistake now than in the examination. Please be a little careful here. Take your time. It's okay to take a little time here. Don't make silly mistakes. Please be careful. This is also a typical gate type question. Little bit of pointers, little bit of arrays, 2D arrays and things like that. Actually, gate questions for C programming are actually not that tricky and hard. They're actually fairly straightforward if you know the concept, obviously. Okay, I see some variability in answers, so please recheck your answer once and correct it if you can. We'll wait for a few more seconds and go into the solution because there are only very few students who answered it till now. So among pointers, arrays, strings, these are some of the most important topics with respect to C programming itself in Gate, because they will also use pointers for questions in data structures like linked lists, etc. So if there is one topic that I have to pick, it will be pointers, then order and precedence of operators and things like that. Anyway, sounds good. So let's tackle this question. This question intentionally there is another thing that some of our mentors say. Recursion is also very important. We will cover that in the next session for sure. So intentionally, we have not given the indentation properly here. So within this for loop, you have this whole thing. Within this for loop, only this thing is there. So let's go step by step. Here we are creating a two-dimensional array. We are creating an integer pointer, integer variables ij. Right. So this is what we have. For I equals to 0, I less than 3. J equals to 0, j less than 5, we are filling aij. That's the structure. So when I equals to 0, what happens now? When I equals to 0, we are filling ai, or in other words, a0, right? So what will a0 contain? Look at this. If I equals to 0, this is 1, right? So if this is 1, 1 multiplied by j plus 2. So when j equals to 0, this will be 2. When j equals to 1, it will be 3, right? So when j equals to 4, when j equals to 2, it will be 4, right? Because this is 1, I equals to 0. Just go through the iterations. Just go through this nested for loop, or also called as a twin for loop, right? Just go through it. So you'll have 5 values here, 2, 3, 4, 5 and 6. This is what A0. Remember, A is basically a two-dimensional array. So A0 is a one-dimensional array, obviously. Now when I equals to 1, what happens now? You're trying to fill in A1, right? If you think about it as a matrix, you fill the first row, you're filling the second row now. Now when I equals to 1, this becomes 2, right? So you get 2 into 2 first, because j will be 0. 2 into 2 is 4. Okay, then look at this. 2 into j plus 2 hasn't changed. All these values are basically j plus 2 values. So 2 into 3 is what you will get next. 2 into 4 is what you will get next. So 8, 10 and 12. Then you have I equals to 2. When you have I equals to 2, you will fill A2, right? So A2 is again a 1D, okay, I keep 1D array, or it's actually a array, right? So because 1D array is an array by default anyway. So what will you get there? So this number now will become 3. So let me just erase this. So this will become 3 now, right? So you'll get multiples of 3. J plus 2 values anyway we have here, that you just multiply with 3. So you get 6, 9, 12, 15 and 18. Done. So you filled your whole 2D array or a matrix basically, right? So this part is done. Now what is P? P is A1 plus 1. So this is where things get more interesting now. So let's go into it. P is A1. So what is A1? A1 is basically a pointer to this whole array, right? So A1 plus 1. Okay. So first you get A1. Okay. A1 basically means it's a pointer to this whole thing. That's what A1 is, right? We have this. We have also written it keeping the pointer notation consistent. So if A1 is going to, because A1 is basically a pointer to an array of 5 elements, right? So A1, you're saying plus 1. Again, remember, what is the data type of P? P is basically a pointer, right? So P is basically an integer pointer. So when you're saying A1 plus 1, which P will be equal to, P will now point to this value. This exact value is what P will point to, because there is a plus 1 here. And what we have, we are pointing to A1, this is 0, this is 1, 2, so on and so forth. So this is where P is pointing to. Now let's go and evaluate this. This is value stored at star. Somebody asked me, what does star mean? The easiest way to read this, whenever you have star P, it means the value stored at the memory cell which P points to. That's how you read star P in English. Learning to read this in English helps. Similarly, if you have ampersand A, it means address of the variable A. This is the value stored at the pointer pointed by P. Right? That's how you read this. So star P basically means what is P point, what is the value stored at the pointer that P is pointing to? 6. So this value is 6. Next comes this P6. Okay, look at this. This is a two-dimensional array. Two-dimensional arrays are contiguous, right? In C programming language, they're all contiguous. So how does this work now? P6. Again, P is a pointer to this. You just, so if you take this as 0, you have to just go 6 locations forward. And first you have all of these, followed by these and followed by this. If this is P0, P1, P2, P3, P4, P5 and P6. So this will be this location, right? So P6 will contain a value of 12. So this value will be 12. Next, you have, again, P itself did not change, right? P itself did not change. Now we are looking at this whole 2D array as a row major. So first you have A0, then you have A1. That's how it is stored, right? In C programming language, you have row major storing. All of A0 followed by A1 followed by A2. Right? This is how 2D arrays are stored in C programming language. Okay, row major order. This is called row major order. I think Fortran uses column major order. Anyway, back to our discussion here. If this is P, you have -3. This is -1. This is -2. This is -3. So P -3 will point to 5. Right? So if you sum up all of this, what do you get? 12 plus 11, which will be 23. So 23 is the answer here. Simple. Right? So this question is all about, can you go through the twin for loop, fill up these values carefully, and then do you understand how pointer, how actually 2D matrices are stored internally in C programming language, and the process of accessing elements here using a simple pointer. That's the whole objective here. This question is typically a 2-mark question by GATE standards. This is considered medium with a little bit of trickiness. It's not an easy question for sure, because there are so many concepts that are intertwined. Okay, but it's not hard, by the way. Most questions in C are not hard. That's the important part. Cool. So let's go to the fifth question now. Again, most of these questions are based on gate question patterns that we have seen, with some modifications, some trickiness added, some trickiness deleted, and things like that. Again, whenever you are doing arithmetic operations on pointers, look at the data type of the pointer. That is the key. This is an interesting question. It's an easy question because the options are easy, but it's a nice question. Let me copy this code and let's do a simple experiment with this. Some of you think that it will print some garbage value. Some of you think it will print an error. Let's see. Actually, I'll show you some code with GCC. The output is very interesting. Again, this question could have been made more tricky, obviously. Oh, it's not an NAT, I'm sorry. It's a MCQ, I'm sorry. No. Okay. Okay, some of you think that A is the answer, okay. Some of you think it's a compilation error. Okay, let's see. I'm very sure it's not a compilation error. Okay, so there are multiple things that are happening here. Again, let's wait for a few seconds before we jump in. I'll copy this code here in the meantime. Okay. I think most of you think A, some of you think D. Within D, there are more clarifications that it will give a compiler error, it will give a runtime error, it will print some garbage value, so on and so forth. Okay, so let's actually run this code, right? So let's actually just quickly run this. Okay, let me just zoom this in. Okay, same code, I just copy pasted it here. Again, this is using GCC, it's printing nothing. There's no compile error, it's printing literally nothing. Now, I have an explanation on what's happening here, but I also wanted to add one more simple printf statement here, right? Just to get a more detailed understanding of it. Okay, so what happens, look at this, look at these two lines here. Okay, let me just zoom this in a little for you. So what are we doing here? We have an integer pointer, we said star p equals to 5, and we are simply printing that value. That's all we are doing. What happens in this case? Let's actually print it. It's still printing nothing. Why is that happening? Okay, so let me elaborate what I thought about it. Again, there can be some compiler specific implementation details here, but again, this uses the standard GCC version. So again, GCC is the most widely used C compiler. So I'll explain you what might be happening. Again, I've not seen the GCC source code to know exactly what's happening, but let me tell you what could be happening here. So we have, again, our main, we are starting here, p equals to fun, we are just calling function. There is nothing that is passed here, cool. So here, the local variable, remember this is a local variable, right? So is this, p is also a local variable, both of them are pointers. The moment you do this, what's happening here? Again, initially p does not have any specific memory value. So which means p is basically a pointer to some integer. right? It's a pointer, it's an integer pointer basically, right? It's an int star. The value that it will have at the time of initialization, it can be any random value. It can be any garbage value here. Now this garbage value, what could be happening here is, let's assume this address is some random value, some garbage value. Okay, so let's assume the value that the pointer itself contains, let's assume is some 10,000. I'm just picking some random number here. In the 10,000 location, there might be some value stored here, but remember that the way the operating system works is, this whole 10,000 memory location could be used by some other process. It could be even a kernel process. So some user process here does not have access to this location, right? That's very important. The ideal way to do this is by using an malloc, right? Where you actually dynamically allocate some memory, which that memory will be available in this function and also outside of it, right? So if you're not doing a dynamic memory allocation, randomly P will have some random value of 10,000, but for the memory location 10,000, there could be some value here, there could be garbage value also here, but this whole memory itself maybe this memory is being used by some other function, some other process, some other kernel job that P doesn't have access to it, right? So that's why even when we just did this and printed it, it's printing nothing literally. So what might be happening here is that's why I added that's why I added this printf line. This printf line is printing nothing, probably because this specific version of GCC compiler might be saying, hey, this P pointer is pointing to something outside of what is available for this process, so I will not print it. Okay, that could be that could be something that's happening. Again, on some operating systems, for some compilers, it could even throw an error, right? So cool. So I just wanted to go through that specific detail. Okay, with that, okay, so P equals to 5. We may not even be able to assign 5 to wherever P is pointing to, because this memory location could be outside, right? We may not even be able to access this whole memory location. So we are not guaranteed that this will go through. But even if it goes through, let's assume it goes through. Okay, we'll think of both cases. Then we are saying value stored at A equals to 20 plus value stored at 5. Some of you thought this will be 20 plus 5, 25, and whatever we have in A, so A will also point to some value, we will place 25 there, right? Again, this may or may not happen because depends on where this memory is. A is also initialized randomly, right? It could point to any memory location in your whole main memory, right? So it could point to anything literally. But now when you're returning A here, look at this, when you're returning A here and A you're returning an integer pointer, right? So remember that A is a local variable here. That's also something that is important for you to recognize. A is a local variable, which means as soon as this function is over, A gets killed. He is no more available for you, right? So that's also important. But broadly speaking, the problem in this code, the fundamental problem in this code is you're not using malloc, which you should use. So you cannot expect answer to be 25 or anything. It will be none of the above. Again, it could be very dependent on the operating system and the compiler that you're using. On this online compiler, we see no result being printed, but it all depends on how internally the operating system and the GCC compiler are working together. Okay, so again, there is a little subtlety here. Cool. Again, the local variable issue is also anyway there. Okay, so let's go to the next question now. That was an easy question because the options are easy. So this is a fill in the blank. Again, it's not a numerical fill in the blank, but please fill in the blank nonetheless. Abhijit, you're right. In set 2 2021, similar question was asked with segmentation error. You're right. Similar question. Again, we didn't want to call segmentation error because you need to understand operating system concepts for that. Okay, so this is the last question of the day. Let's solve this. Again, this is not a numerical answer that you have to fill. I'm just making that clear. Again, some of you are asking variations of the previous question. Just open a online compiler and just modify the code slightly. Right? For anything, if you have follow-up questions on how things work, it's just a browser window away. Play with the code. That's a great way for you to learn concepts. Anyway, let's focus on the 6th question now. After this, I'll take general questions. Again, please be careful with the pointers here. This is slightly tricky. Good to see most of you getting it right, with some of you making silly mistakes. So please be careful with the silly mistakes. Again, this is like a medium tricky question by gate standards. Most of you got it right. Some of you have made silly mistakes. Always draw, always draw. Look at what's happening with the pointers. This is a typical 2-mark type of question, medium with slight trickiness. Okay, I'm happy to see some of you have corrected your answer. So let's go through the code. So what this is saying is that there is a function called fun1, which is there below. And this is like just informing main that it is available, and this is the signature, or this is the declaration of the function. So you have char a, this is basically a is now a array, or in other words, a is a pointer to reach, right? So this is what you have. Of course, you have a \0 also because it's a string, right? So reach \0. So this is locations 0, 1, 2, 3, 4, and 5. Okay, cool. Now you have a void pointer. Remember, void pointer can point to anything. But if you want to access something, you can't use void pointer. You have to do typecasting. Typical stuff, typical details about a void pointer. Now temp equals to a. So this is a void. Remember, temp is a void pointer. It's very, very important to remember its data type, right? Now we are saying fun1 temp. Okay, so we are pointing this. So this temp is now called as temp1 locally here. Cool. This is all cool. Now t1 equals to 0. Now look at this expression here. What is it doing? It is first taking temp1. Temp1 is being typecasted as a character array. Okay, temp1 is now typecasted as a character array. Now to this character array, we are adding t1 plus plus. This is a post increment, so we don't have to worry about it. So now temp1 will behave like because we're doing character pointer typecasting, this will now behave like a character pointer, because I mean not exactly temp1 but char star temp1, that's what I mean. A char star temp1 will behave like a character pointer. To that we are adding t1. T1 is initially 0. So what happens when t1 equals to 0 first? It will be used. So we'll check whether it is, if it is not equals to \0, right? So what is, remember, what is, when this is temp1 which you are typecasting into a character array, right? And then what are we doing? We have this star also here. Don't forget this star. This star basically means value stored at this. What is the value stored here? The value stored here is r. Value stored at the pointer, the character pointer that is pointed by temp1 is r, right? This value is not equals to \0, right? It's not equal to. So you'll go into the loop. Within the loop, what are you doing here? So t1 is initially 0. You go into the loop. What is happening in the loop? Again, by the time you go into the loop, your t1 is incremented because there is a post increment here, right? So t1 became 1. That's important to note. And now what is being printed here? Again, you're doing the typecasting of temp1 plus t1. Look at this, plus t1. So if you just do a typecasting, it will point to this plus t1. T1 is now 1, right? T1 is 1, right? Which means plus 1. And you are saying what is the value stored at that. So it will print E now, because if this is the 0th location, this is the first location, right? So you're getting a character pointer here. To the character pointer here, again, you know this simple notation, right? A1 can be written as star A plus 1. This is how you can convert from array notation to a pointer notation. Standard stuff in basic C programming. Same thing is happening here. Okay, so your character pointer temp1. So this is basically a pointer to this, and you're adding 1, which means you will go here and you're saying what is the value stored here. So it will print E because it has %C. It's not %S. Right, it's only %C, so it will print E now. Okay, the loop will keep continuing. Next time what will happen? Look at this. Next time again, okay, so let me just erase this. In the next iteration, what will happen? This iteration is very simple to follow. Next time, the standard, same thing. So you're doing the typecasting, you're saying T1. T1 will initially be 1, then it will get incremented, right? So T1 will be 1, then it will get incremented to 2. So when it is 1, we will use it, which means where will we point to? Now, because we are typecasting and then adding 1, we will point to this location. And we are saying what this star basically says, what is the value stored here? It is E, right? Because it is E and it's not equal to /0, literally what's happening here is we are checking if a value is, if the next value is /0, look at this, we are just checking E is not equal to /0, so we will print the next character. Done, right? Because T1 is getting incremented. So what happens? This loop will go on till the time we reach this end. This will happen till the time we reach this end. So what it will print, literally what it will print is EACH. This is what it will print, right? So let's look at the termination criteria, right? Very simple. Okay, very, very simple code, straightforward code. Again, this is not rocket science. It's all about knowing about void pointers and typecasting. Okay, with that, we wrap up today's questions and let's get into the Q&A. Okay, sounds good. So let's tackle the questions now. Again, I have the chat window open here. Feel free to ask me. I will try to answer as many questions as possible. There is a little trickiness in some of these questions. Again, in gate questions, you can expect a little bit of trickiness. So Pratik says, I'm covering 3 to 3.5 hours of lectures daily and gate PYQs topic wise. That's a good strategy, Pratik. Don't worry. And don't expect results immediately. It will take time, but eventually you'll reach there. If you're putting in 3 to 3.5 hours of effort, that's a good start. Keep the momentum, keep going through it. Also try to solve the previous year questions in our, not the previous year questions, I'm sorry, the practice questions along with your PYQs that you're solving. So file handling in C, yes, it is there. I believe the next live session has that topic covered. Just let me just check quickly, please. The next live session is, just give me a second. So we have C programming, yes. So we have structures, unions, dynamic scoping, files, and some miscellaneous topic for the next live session. Yes, it's there. How to build research mindset, like problem solving mindset. Again, research mindset, you typically get it by reading a lot of research papers during your graduate or during your PhD days. That's the best way. People typically spend 2 years to build the basic mindset by reading tons of research papers. That's the only way. That's why for most research, people join a PhD program. People get a flavor of it during their masters, but it's the PhD program where they get to do most of the serious work. Should I opt for internship in 7th or 8th semester? It's okay. Whichever semester it is, doesn't matter. Just plan your gate preparation or your other details accordingly. It should be okay. Suppose if you're interning in 7th semester, plan accordingly. If you're interning in 8th semester, plan accordingly for gate, right? So it's okay. Any semester internship is okay. Internship is always good. Is it safe to finish syllabus in October? It's actually very good if you finish your syllabus by October. It's actually very good because you have like November, December, Jan and 2 weeks of Feb, almost 3.5 months to revise. That's great if you can. But again, don't worry about the speed at which you're completing iteration 1. It is the rigor with which you're completing iteration 1 that matters. I've been telling you this every time. It is the detail, it is the revision plan that you have in iteration 1 itself that is important. Please don't ignore that. Okay, somebody says, which topic or subject do you personally have a dislike or difficulty with? When I wrote my GATE exam in my 3rd year, I was part of Andhra University, and we had a very old syllabus. So a lot of GATE subjects like computer networks, compiler design, they were not available. We had them in our 4th year. So I struggled a little when I wrote the GATE examination in 3rd year, but when I actually wrote the examination in 4th year, there was no specific subject where I was really lacking, because I tried to enjoy every subject by connecting it with things like even computer networks, right? When I actually learned it in my 4th year, 1st semester thoroughly, I actually used tools that actually we use in the course videos, right? So we use all these actual network sniffers. Actually, I show you actual packets using those network sniffers. That's how I learned computer networks even in my BTech. So I enjoy concepts when I connect them to real world aspects. So I didn't have anything that I was particularly not interested in. I enjoyed hardware subjects earlier in my BTech, but later on I fell more into the machine learning subjects, image processing. We had a subject called neural networks in our 4th year, I think 1st semester or 2nd semester. So I went into more math topics. I was thankfully fairly good at math in general, but I also enjoyed almost all the subjects. So 3rd year I struggled, but final year, not big deal. My 3rd year rank, I think, is 176 or 178. I keep getting confused. I think it's 176, my 3rd year GATE rank. Good score to be in the top 100. Aman, I think if you're getting about 70 plus marks in the GATE examination, you have a fairly good chance to be in the top 100. Fairly good chance. Now, if this is about the scholarship test, we don't know. Like every year, the marks change. There is no one answer. It depends on how many students are writing. We are expecting significantly more students to write this year than the previous year. So it all depends on students who write. We can never predict what will be the top 100 ranks in scholarship test. Yes, this is a very nice question by one of the first year students. Should a first year student refer standard books who is aiming to crack GATE? Yes. If you're a first year student, there are 2-3 things that you should focus on. Become a good programmer, become really good at C programming, data, or any programming language that you have as part of your coursework. Become a good programmer because that is essential for computer science. It builds your problem solving mindset. It sets you up for life. If you ask me, the most important thing you should do in your BTech first year is write as much code as you can. That's very important, and try to read from standard textbooks, the good textbooks. Again, different universities have different textbooks. You can just Google, look at any top university, look at their reference books, textbooks, just follow them. As simple as it. For example, the Introduction to Algorithms, CLRS, was not the standard textbook when I was studying my BTech, but I just Google searched and saw what top universities were using, and the book is available in India at a reasonably low price. I just got it from the market. I mean, we used to buy books in the market then. E-commerce didn't exist. So went to a bookstore in Vizag, got the book, and I started reading it. As simple as that, right? So please, if you're a first year student, focus on programming. Equally importantly, please focus on reading as much as possible from standard textbooks, because you have so much time, right, to build the skills. So somebody, Parag says, I'm using Python these days, but coming back to C, I'm struggling. Parag, same thing happens to me. I often miss semicolons at the end of the line in C code. Happens to me a lot. I write print instead of printf. But if you know the C concepts, that's enough to solve gate questions. You don't have to be an expert C hands-on programmer for gate, because you don't write C code, right? So, I mean, what I would suggest is just go through the concepts thoroughly, especially concepts around pointers and things like that. Everything should fall in place because you have the programming mindset. That is important. The moment you have that, everything else falls in place. So just get comfortable with the syntax. Like, I'm not very comfortable writing C code because I don't write, like, less than 1% of code that I write is C. And I write it mostly for these types of live sessions, or I read C code when I have to read the documentation underlying some C implementation of a Python mathematical function or a C++ implementation. Otherwise, I don't write much Python code. I don't write much C code, so I'm not very comfortable writing large code in C, but I know the concepts. That's how I think you should look at gate prep. Computer networks is my favorite subject. What are the career opportunities for CSC students? Again, you can always join companies like Cisco, etc. But I mean, okay, Cisco is still okay-ish company, not the best of companies, but the best of networking guys that I've seen slowly translate into distributed systems, because there is a lot of overlap between the expertise that you gain in networking and what you can do. I mean, they also work on like large scale, high throughput systems, right? So they typically go into that high throughput distributed computing for internet companies and things like that. And that's a great place to be, because with huge amounts of data being created and with millions of users hitting servers, like for example, imagine if you're designing something for Netflix, you have to think of so much details about the UDP protocol, right? Because every packet that you stream of video content via UDP, you have to think how the whole thing works. So there are some of these interesting companies like Cisco for sure, but if you also learn some of the engineering aspects related to distributed systems or high scalability systems, it opens up a lot of doors at engineering teams in almost every internet company in the world. Sai, very happy to see this. You said your algorithms marks increased from 2 questions to 6 questions. Very happy to see this. I mean, that's a good progress, right? So you got 2 questions initially correct. Slowly with improvement, you got 6 out of 15 questions. That's about 40%. Again, we have a video on our YouTube channel which gives you general guidelines on how to consistently improve in your performance. It is through debugging where you made mistakes, writing notes of your silly mistakes, struggling with a question instead of immediately seeing the answer. General guidelines that we have. Please check that video where we give all these general guidelines on how to build the problem solving ability. The same thing applies to almost every subject. We also discuss about drawing things, visualizing things, and like same thing that we did today here in C programming, right? We drew how memory was organized, what is pointing to what, and things like that. So there is a detailed video on our YouTube channel. Please check it. I'm hoping that from 6 questions you reach 10 questions soon. Very happy to see this. What's the scope if we do MS in US but wanted to live in India? Again, as long as you're doing a top quality MS program from a top university. I mean, I have friends of mine who have done masters and PhD from universities like Carnegie Mellon, like my colleagues who have done from University of Illinois, Urbana-Champaign, Stanford, etc., who work in India, right? Who work with internet companies in India. Like, you're treated as long as you have done a very thorough degree, very rigorous degree from a top university, it's equivalent to doing, or sometimes it's even better than doing a degree from a top university in India. There will be very little difference. Harsha says, is the research work in CSC saturated? Not at all, not at all. I think we will see miraculous things in the next 20 years that we cannot even imagine today. So CSC is probably one of those more active areas of research across the spectrum. You take anything from operating systems, distributed systems, computer networks. There is a lot of interesting research that's happening, and with computer science centric companies being some of the largest companies in the world today, whether it's Apple, whether it's Google, whether it's Oracle, whether it's Facebook, whether it's Amazon, right? I believe that there will be a lot more scope to solve real world engineering and science problems using fundamental computer science research. I see that a lot in machine learning, but it's not just limited to machine learning. Like for example, if you look at Spark, which is a very popular distributed systems platform, it came out of the AMP lab at Berkeley. Berkeley has a very, very strong distributed systems, operating systems, databases type of group, right? It came from those systems groups, and it is literally world changing in terms of its actual impact. And people who worked on that project also got PhDs, and their PhD is translated into a product, and it's world changing. I've seen that whole thing happen. So there is a lot of scope for CSC research to be highly impactful, not just in machine learning, but across the board. Cool. Tips for PGE. I think you're talking about the IIIT PGE. So we have a video, if I'm not wrong, on our YouTube channel about the IIIT PGE. So IIIT PGE typically focuses on only some topics, mostly programming, data structures and algorithms, and aptitude, if I'm not wrong. Again, one of our co-founders, Naveen, studied at IIIT Hyderabad. So I believe, I've not written PGE myself, I believe these are the topics that will be the key focus. So as long as you're a good programmer, if you have revised, just revise programming, data structures, algorithms, and aptitude, because I think that's what PGE will mostly focus on. So this is Ayub says, I'm a working professional. Please discuss how I can prepare for GATE. Again, the difference between you and a student is simple. You have a scarcity of time and you have other work that you have to do. Students can skip classes and things like that. As long as they write exams, they're done. In your case, the suggestion for any working professional is simple. Try to squeeze out time early in the morning or late in the evening, and squeeze out at least 3 hours. Try to have that focused mindset for 3 to 4 hours a day, and I think you're good to go with that. Of course, I understand that you have more responsibilities than a student, but you also have more maturity, right? So you have to learn to utilize your time more aptly. Again, we have a whole video on how to chunk your time into 90-minute videos, how to make the most out of it. Please check that video on our YouTube channel. Cool. How many marks did you have rank 1 when you had, I forgot actually. We used to have a 150 mark question paper. Again, in those days, I don't think I got my answer sheet. I could only verify it using other answer sheets that others provided. I believe out of 150, I don't remember the exact marks. Probably I got around 120, 125-ish in 2007. This was long back, and we didn't get the answer sheet, so I actually don't know. This is a guesstimate. So yes, there is this alias called Gate CSC concept through questions. Yes, so in the scholarship test, you will have good weightage of marks. Again, if you go to the scholarship page itself, we say how many marks you'll get from each topic. If you're even good with data structures algorithms, you can be in the top 100. Reasonably, again, that's a guess that I'm making, but very likely. Good question. This is what's your view on PSUs for CS students? There are some PSUs. We have interviews of students who got through these PSUs on our YouTube channel last year. So again, PSUs are on and off, unlike mechanical engineers, electrical engineers, etc., where they have a constant hiring every year. The PSUs for CSC, every year they change. There are some like Baba Atomic Research Center, etc., which hire more regularly. DRDO has their own exam, ISRO has their own exam sometimes, and I mean, there are some of these institutions which are terrific. Like Baba Atomic Research Center, we don't hear much of it because it's mostly national secrets, right? I mean, they can't even discuss their work publicly, but it's extremely high impactful work, no doubt about it. Similarly, some of the work that is being done at DRDO, most of these people can't discuss publicly about it. But I'm sure it's terrific work because I worked with a few ex-DRDO folks in various organizations, including at Indian Institute of Science. So, I mean, surely the quality of work will be good. There will be obviously job security. And again, it's a lifestyle / career choice that you have to make. Okay, it's not for everyone. Again, I'm sure there are some people, we have had students who didn't join top universities but joined PSUs. That's perfectly all right, and they're very happy with it. Okay, so please check out some of these videos that we have on our YouTube channel of some of the students who went to PSUs, their perspective and their decisions on why they went there. Some of those are very interesting. Like we had somebody who cracked, if I'm not wrong, both DRDO, Baba Atomic Research Center, and also ISRO, if I'm not wrong. And he ended up with Baba Atomic Research Center because he felt very passionately about the nuclear energy needs and how he can play a role. Cool. Okay, I think. No, I hate my beard. I was just too lazy to shave. My son hates it more than I do. Anyway, so I was just too lazy with other stuff. Okay, folks, I'll shave it off. Thank you very much, and see you in the coming session. And again, as usual, as always, please stay safe. Don't get your guard down. Double mask, wear a shield, step out only if necessary. Again, I'm very serious about this. I'm telling this in every session because if you fall sick, it's going to hurt your preparation. It's also going to create chaos within your family. Please don't do that. And if you can get vaccinated, please get vaccinated. Okay. See you folks. Bye-bye.